This video describes the assembly, the setup, and the operation of a custom-designed automated Accu-Slice system that we custom designed for a customer. The customer of this system wanted a system that would cut boards up to 36 inches long by 6 inches tall for making backs and sides for guitars. The system is very similar to our previous systems with a few minor modifications. First of all, we use a longer linear ball screw. This ball screw has a travel range of 1200 millimeters. This will enable the cutting of boards up to 40 inches long. Next, we use a linear actuator for the indexer that has a travel range of 4 inches. This will enable the cutting of thicker boards. Finally, we modified the mounts for the Hall sensor to enable you to cut longer boards, and we also added some new mounts to go underneath the rails and the linear ball screw to reduce vibration to give you smoother cuts. This system will ship in 5 separate boxes, so the assembly is a little more complex. Therefore, we're producing this video to show how the system is set up and installed, and at the very end of this video, we'll demonstrate the actual cutting of some boards that are 36 inches long by 6 inches tall using this new automated Accu-Slice system. Okay, I have all my components for the automated Accu-Slice system ready for assembly, and the components consist of the Accu-Slice index table, the indexing linear drive, my ball screw linear drive for the total length of travel, a 6-foot rail, the Accu-Sled 2 carriage, the electronics console. We have 2 Hall sensors with offset mounts, 2 electromagnets with the mounting hardware, of course electronics console, electrical cable, another cable to hook up in case you need to download the software, and spacers. If you have your extension tables at a lower height, you need to raise them up. This is just to give you additional support to reduce vibration. And then a mount for the carriage. Our system is a standard Accu-Slice AS266 index table with a few modifications. The front bar here on a standard system is 1.5 inches wide. This bar is 3 inches wide, and we use a wider bar because of the larger indexing system. Likewise, these guide bars on the side, our standard bar is 12 inches long. This is a 12-inch bar. These bars are 14 inches long, and they need to be longer because of this wider plate in the front. Again, this plate is wider to accommodate this 4-inch travel index system to give you greater travel distance. Now, this plate was modified in a few different other areas. First of all, we added additional slots here for the electromagnets to be installed, so they'll be mounting in here in these slots. We have holes drilled in these plates for adapting and mounting the indexing system. We also have holes here for mounting my linear ball screw. And now we're ready to start the assembly. So the first thing is probably to attach the indexing system. Now the system has a separate plate here, and the holes will line up on the plate here, and this front edge should be flush with the front edge. The back edge overhangs a slight amount. And then there's holes here for mounting this bracket. So probably the first thing to do is just put that plate there in the approximate position, and then we'll go ahead and mount these 3 holes. And we'll have 3 bolts that will screw into that plate to hold it in position. And this is just a standard 5/32 Allen driver. Then we turn it upside down to mount the other screws. What I'm doing here is aligning the holes between the front plate, the spacer, and the indexer linear drive. And just mount everything up with there's 8 bolts that go here. These are all flathead screws. There's 8 of them. Probably don't need all 8, but I drilled it, so I might as well put them all in. And these are a 3mm drive. They're metric. These are number 5 metric screws. And just snuggle all those up. Okay, while it's upside down, the next thing is to mount the linear ball screw. And they mount in these two holes on each side. And they're mounted with 4, again these are metric, M4 metric by 10 millimeter long screws with a hex drive. And I want my stepper motor to be on the left side on the bandsaw, so that goes underneath here. So I just take this, again turn it upside down. On this linear ball screw there's a bunch of nuts on the bottom of the rail, and I want to leave 2 nuts on the far end for my spacer that I'm going to be putting that. So I do that on both ends, make sure there's 2 nuts there. And then in the center I'm going to use 2 of these nuts on each side to mount my Accu-Slice index table. It doesn't matter which of the bolts I use, because as long as I have 2 here for the end pieces, that's fine. Any of these other screws can be used. So sometimes I just put a bunch here so it's easier to align when I'm actually putting the table on the top. So this table is going to be mounting on this rail, screwing into these 2 of these nuts on this plate. So I just get 2 of them aligned initially. I'm going to put a spacer underneath here so it doesn't move on me. Keep it level. And just try and line up 2 of the nuts, and then we'll screw them in place with 2 of these. Again, they're M4 by 10 millimeter long screws. And these are 2.5 millimeter metric. That's right. I sometimes use a wooden stick just to push these nuts through to try and get alignment. One end, same thing, just use my screw to push it till I see the hole lining up. And then screw that in place. I just put these screws in initially finger tight because these are going to be loosened later when it's on the bandsaw, or anytime you want to change the position. You can just loosen these screws and then change the position of this anywhere on the rail. It depends where you mount your Accu-Slide 2 table, where you want to put that. So for now I'm just going to make them finger tight, just so it doesn't move as I mount it on the bandsaw. And next, while the system is still upside down, I can install my spacers. You may or may not need these brass spacers. These are used because both my Accu-Slice rail and this linear ball screw are 1/4 inch above my tabletop. So these spacers go underneath to make it the same height as my table, so it reduces vibration. And this again uses these are metric number 4 round head screws, and it just mounts using those 2 nuts. So you may or may not need this depending how you support the end of your rails. I made extension tables on my bandsaw, so I need these to bring it to the same height as my tabletop. And these go in this direction because the rail is going to go in this position. So it supports both the linear ball screw and also my Accu-Slice rail. So that completes the bottom installation of the components. In the upside down position, I attach my drive for my indexer. I attach my linear ball screw with 4 screws, and I attach my spacers. So now I can turn this right side up to finish the installation. if I loosen my force adjustment knob, I can move this to where I need a position. Again, I want it where I can have access to these offset cams too. So next, let's install the electromagnets. There's two electromagnets, and I did label them. This one's marked left, but there's an L, and this has an R on it for right. And you want the wires facing towards this direction, not towards the rail. And these are mounted with 4 spacers and these are 4 1 3/8 inch long screws. And to install these, you put the spacers underneath there, insert 2 screws, and these get mounted in a slot. There's a large hole for the magnet, and then 2 tapped holes in the plate. And it should just screw in position. This uses a 3mm hex drive. And again, you want your wire facing this direction, not towards the rail, because it'll be in the way if you put it on that side. So you just snug those up. If you ever need to adjust the height on these, if the magnet's too high, you can just take these spacers and sand them down a little bit. If it happened to be too low, you can put a spacer in there, a thin washer, to raise the height. But they should be accurate. I set them on our system and they should be right. Again, the same thing. 2 spacers. Like that. And just mount it in the hole. And you don't need to over tighten these, just get them reasonably snug. Next we have our Hall sensors mounted on these L brackets. And again, I put a label on these. This one's for right, and this is for left. And the reason I made these an L bracket is to, this again mounts and screws on this rail, is to get it beyond the end of the rail so you get the full length of travel on your ball screw. So it just gives you another inch of travel. And again, this uses the same screws on the system. Uses a thumb screw. Again, it's a metric thumb screw. I prefer to use the very last nut so it goes the whole way to the end. And the same thing on the opposite end. Gotta like using the last nut. One additional item which may be removed for shipping is this plate. This plate mates the ball screw with the carriage on the which is mounted on the rail, and it mounts to this hub here on the linear actuator for this ball screw with the 4 screws. And these are just held in with this is a 3mm hex head screw, and that can easily be removed to remove this. And I may remove that just for shipping, but for now I'm leaving it on. Now that's it for now. We'll put the rail on later when it's on the bandsaw. The less you put on now, the easier it is to move. I'm now ready to install the Automated Accu-Slice System on the bandsaw. The 2 adaptions to the bandsaw are required, and these are the extensions on the front of the table and extensions on the left and right side of the bandsaw table. These extensions on the front of the table actually extend out 4 inches past the front of my table. They're made out of some angle irons, which are 4 inches by 3 inches, and they're bolted to the front of the table. I drilled and tapped holes into the cast iron table and then screwed them in place. Before I did that, I put these on my mini mill, and I used a fly cutter to get them perfectly flat and sort of be flat with the top of my bandsaw table. And then I polished them a little bit to get them smoother. And they're adjusted such that they're perfectly flat with the top of my bandsaw table. These are needed for 2 reasons. First of all, the Automated Accu-Slice System has a lot of weight on this outside edge between the extension guide bars and the front plate and especially that indexer with the stepper motors hanging way out here, you have a lot of weight in this outside edge. And if you didn't have some extension here, it'd be easy for this whole table to tilt and fall while you're trying to install it. So he's giving you some additional support to prevent that from happening. The second reason they're needed is for the electromagnets. And again, that's why they're made out of iron. The Accu-Slice system, the Automated Accu-Slice system, has two electromagnets which extend further out. And with the longer linear drive for the indexer, those magnets need to be able to attach out here a little bit further. So I made these to 4 inches wide. You want something at least 4 inches wide, maybe even 5 inches wide to give you more support there. The second thing you need is support on the outside edges of the bandsaw table, both at the left and the right. Again, the Accu-Slice index rail is 6 foot long, so that hangs way out both sides. And the linear ball screw is 1200 millimeters, so again, that's very large and hangs out on the far side on both the tables. And if you didn't have some support out here, you get a lot of vibration both in the rail and the ball screw. And that vibration will give you rougher cuts. So you want to minimize those that vibration so you get smoother cuts. So these tables, again, are perfectly level with the top of my table. And I can get my systems to mount and reduce vibration by having it resting on the edge of the table. So you use this table, or you can use those roller bars to support both the Accu-Slice rail and also the linear ball screw. Again, just to reduce vibration so you get smoother. So now we're ready to install the Accu-Slice system. I have my assembled automated Accu-Slice system, and I just mounted it into the miter bar on the bandsaw. And again, those extended tables on the front keep this from tilting as much as possible. It's still heavy, but you gotta have some additional support there to support that. And the first thing to do is I usually lift this up a little bit to make sure it sits down flush in the miter bar, and then lock it in place. I want to make sure it's centered in my system. Make sure it goes all the way into the bandsaw blade. And then make sure those all are locked in place. Next, I need to install the rail. And I'm using the 6 foot rail. Notice that the rail goes over top the brass spacer. This is used to reduce vibration to give you smoother cuts. And next I need to install my Accu-Slice 2 carriage. And I use my plate here to adapt the plate to my ball screw. And I usually use this, one of these two center positions to screw it. I have a spacer here which goes in between the plate here and either the first or the second. And where you position this determines where your end points are. So you may want to adjust the ball screw accordingly. And the way that's done is just by pulling this out some to the point where I can reach the screws underneath here. And I can loosen those underneath using my 2.5 millimeter Allen screw. So I loosen those 2 Allen screws and do that on both sides. So once they're loosened, then I can move the entire ball screw left to right. And you may need to do this after you adjust your rail. And then when you're done, retighten those screws. Kind of cumbersome to adjust because they're way underneath there. And I couldn't use thumb screws because they have to slide on top of the table. So next we need to install the electronics control. And this particular system was designed, the electronics console goes on the left side of the bandsaw table. So I'm ready to start hooking up my cables. I have 6 cables that need to be hooked up. This is the cable for the ball screw. And some of these cables are color coded. The red cables go on the top position and the black cables go on the bottom position. Here's my one of my Hall sensors. Here's my electromagnet. Stepper motor for the indexer. And the final Hall sensor. I usually run these cables inside these mounts for the electromagnets so they don't get caught up in this slot between the two tables. Okay, turning the electronics console to the back position, we have 6 inputs for the various cables. We have 2-pin, 3-pin, and 4-pin. The 2-pin are for the electromagnets, the 3-pin are for the Hall sensors, and the 4-pin are for the stepper motors. So starting with the electromagnets, there's 2 cables, and it doesn't matter which goes which. They can go either place, either top or bottom. These aren't, position isn't critical at all. But on the top of each of these connectors, there's a slot, and the slot is designed to go to 12 o'clock. So all these are set that the slots go at 12 o'clock position, so you can easily get those aligned, and then screw them in position. So that's the electromagnets. The next 2 are the Hall sensors, which are the 3-pin connectors, and these are color coded. The red goes up top, again with a pin to the 12 o'clock position, and the second one, it has a black connector that goes in the bottom position. Next we have the indexer. Stepper motor has a black connector that goes on the bottom. And the final one is the stepper motor for the ball screw, and it has a red handle. So that goes on the top position. On the back we have a power connection and an on-off switch. This connector here is for an input for the Arduino software. If you ever need to reinstall the software, there's a cable which plugs into there, and this gets plugged in your computer so you can download the software. An electronics console has a number of connections and switches. The first one is the emergency stop. That turns off the power to the complete system. So it's a quick way to totally stop everything. If anything would happen, the bandsaw blade coming off and getting misaligned or something, you can just press this and that stops everything automatically. Just a quick turn to release it. We have a series of buttons on here. These first 2 are for the magnets. I can turn the electromagnets off and on manually. These next 2 are for a manual jog. I can jog my carriage left or right manually to do alignment and adjustment. This is my button for the automatic operation. These 2 are buttons for the running of the system manually, so I can do a manual run and stop. And this is buttons for the manual control of the indexer. And this is a reset button. If you're ever doing something, you need to reset the system rather than turn the power off, you just press reset and that'll restart the entire system. And when you first turn it on, all the lights go on, it shows you everything's working. And then you have to input data. It's asking you for 4 pieces of data. First of all, it's asking you for the board thickness, how thick of a board you want to cut. And you use this dial to dial in exactly how thick of a board you want to cut. After you made that adjustment, you press enter. It next asks you for the size, thickness of your blade kerf. Usually my blade kerf is 45 to 50 thousandths. Again, I use this knob to adjust that dimension, and then press enter. Next it asks you how fast you want the system to cut your boards. And I like to cut around 10 inches per minute, so I adjust that to 10 inches per minute and press enter. And then next it asks you how fast you want to reverse it. I like to reverse it much faster so you don't waste a lot of time waiting for the system to get back to normal. So I usually maybe set that to around 50 inches per minute and then press enter. Now all the lights go out and it's telling you it's in the stop position. If I wanted to run this manually, I'd press the green button and it would go through a sequence manually. Then I can stop it at any time just by pressing the stop. These manual controls that I mentioned jog the system automatically back and forth manually, so you can do adjustment. And this is usually used during setup, where you need to adjust your hall sensors, both the left to right positions, and also to adjust your distance of your board from your bandsaw blade. So that's what they're normally used, just for setup. As I mentioned, these turn your electromagnets off and on. I turn the magnets on now, and then I just turn them off. And again, the light goes on when they're on, and off when they're off. And these lights indicate what's happening, whether it's running or not running, and they actually cycle through as you're doing a run, either a manual run or an automatic run. The indexer controls, again, are used to do a manual control of the indexer. I can step it forward by pressing the run. It'll step it in the thickness of your board plus your blade curves for a manual setting. And reverse is used to automatically return it to the starting position. You use that when you first run a board. The auto run, and when you press that, it'll ask you how many boards you want to cut. It'll tell you how much wood you need to make the number of cuts. And then after you select that, you press the enter, and it'll begin the run to automatically run those boards. So that pretty much completes the installation. Next we need to add some L brackets to my carriage, and we'll mount a board on here and we'll cut some boards. So I installed 3 of the 4x6 L brackets to the carriage, and kind of made the board was centered on both sides, because it overhangs the carriage by a little bit. And then screw the L brackets into the carriage with the bolts and the set screw, the brass keys, and then attach it with wood screws to the sacrificial fence. Again, keeping everything centered. So next I have to set the hall sensors. It's very important that these be set up accurately. I want a gap on both sides of the board, both on the in-feed and the out-feed side, to give me a little bit of clearance. And I'd like to have maybe an inch, inch and a half of clearance on both sides, if at all possible. So I move the hall sensor over, and then get that gap adjusted to where I want it. And then I index the table to move to the right. And on the right side, it's important you have good clearance and make sure you have that set up properly. If you don't have that set up properly, and if your board doesn't cut the whole way through the system, and then you try and run it backwards, it's going to bind up your blades. So what's going to happen is it's going to, cut through the board, maybe not get the whole way through, and then move the board, fit 1/20,000 of an inch, binding the blade, and when it backs out, it's going to give you a lot of friction and cause some problems. So it's important that hall center on the right side be set up accurately. So now I move the board back to close to the starting position, and then I'll set the starting position for the first cut. So just push the Accu-Slice system in till the board just touches the bandsaw blade. And notice I'm pushing on both sides of the Accu-Slice carriage. You have a lot of weight on the system, and if I pushed on one side more than the other, it might give me a cocked system. So I always push evenly on both sides of the table till it just touches the bandsaw blade. And then I lock the index table in position. Now in getting ready for my first cut, after I set up my position for the blade, I move the carriage back till it touch the hall sensor. And then once it touches the hall sensor, it's very important you move it forward so it doesn't touch the hall sensor. If you try making a run where the system is still sensing the hall sensor, it'll give you an error. It'll index the board and not do a cut, and you get your whole system out of alignment. So it's very important, after you do your alignment of the board touching the bandsaw blade, move the board back till it activates the hall sensor, and then move it forward to the red light on the hall sensor is turned off, and then you're ready to run. This board is a hard maple board, and it's 36 inches long, 6 inches tall, and about 2 inches thick. It's a pretty heavy board, of course mounted to a 3/4 inch piece of MDF. And I'm going to run this in the automated mode, and I have my system set to slice boards 100,000 of an inch thick, that's 0.100. My blade curve is set to 50,000 of an inch. I'll be cutting at 10 inches per minute, and then reversing at 50 inches per minute. So running the automated mode, I press auto run. It's set for 6 right now. I'll change that to 4. And it tells me I need 0.600 inches, and I have 2 inches. I have plenty of boards. And I just have to turn the bandsaw on. I sped the video up here 20 times the actual speed. So I'm running 4 boards continuously with no interruption. And after I ran these boards, I checked them all with a vernier, and they're all within plus or minus 3 to 4 thousandths. Because I'm slicing at this slow speed of 10 inches per minute, it takes a full 4 minutes for each slice off this 36-inch long board. The board surface is very smooth with minimal saw marks. Well, I cut a total of 14 boards off that. Started off with a 2.5 inch thick board, which was 36 inches long, 6 inches high, and 2.5 inches thick. And I first thought that was maple, but it's not maple, it's poplar. So I got some green in the board. But the surfaces are pretty good. Towards the end, I'm starting a little more vibration, probably because the blades may be getting dull, or maybe there's some sawdust building up on the wheel. But at the beginning, it was nice and smooth, but it's getting a little bit rougher as I was cutting the last couple of boards. But that was 14 boards I cut off of that. It's quite a bit of wood. And they're all nice and straight. They're probably parallel within, 3, maybe 4 thousandths of an inch, plus or minus 3 or 4 thousandths of an inch. But it's pretty good. So that just completes the setup and testing of the automated Accu-Slice with the 1200 millimeter linear ball screw and the 4-inch indexer.